Warm welcome to all of you. Surya Buddha, I can see you. Just do let me know that am I audible and visible to all of you. Hey kids, today's this session of D block is going to be marvelous. The awesome one. Timing is 7 to 9. Exactly at 9 p.m. I will complete this lecture because everything is sorted. It's happening. Why it's okay if I put it over here. 1111, warm welcome. Now, just to let me know, everyone, if I'm perfectly audible and visible to all of you. Yes, it's to let me know that Baba is audible and visible to all of you. Can you hear me? Can you see me, kids? I want to see green hearts if I'm perfectly audible and visible to all of you, kids. Quick. Do let me know because I can't see the messages running very fast. Yeah, right now D block. Right now my prime focus is D block. It's clearly mentioned over there. Sham has shared the fire. I'm waiting for rest of others. I don't know why people are not writing over there that yes, Baba, H.S.P, you're perfectly audible and visible to us. 1111, very good. Sham, very good. Where is Ifi, Ritvik, and everyone? That's fantastic. What I can see, 1111 is there. Sham is there. So we are going to start with the trends of D block, right? Fantastic. So D block part 2. Here we are with D block part 2. D block part 2. Yesterday we have completed KMNO4. Yesterday we have completed potassium dichromate, each and every reaction of potassium dichromate and KMNO4. So just do let me know in the chat section that the voice is clear or not. The voice is okay. I think it's okay. Just do let me know. Write down in the chat section that it's okay, that it's loud and clear. If it's loud and clear, do let me know. Yeah, questions also there. The questions, previous year questions. I'm here with 20 questions, the best option. 20, those questions which already been asked, and 20 questions I will give you from my side. New questions, right? Is it clear? Very good. Thank you, 1111. Thank you. Thank you so much. Now, my dear students, let's go with the flow. So here the questions you can see, these are the questions on your screen, but we will be able to solve these questions only once we are having an idea about the whole chapter. So is everyone ready? Roshan, yeah, definitely I will. So are you ready? Is everyone ready? Ready, sir. Okay, let's see. Let's it go. So first of all, I would like to talk about the oxidation state. Already we have done. I would like to talk about first about the atomic radii. Do you know atomic radii? If you see this chart, let me make it a bigger one. Zoom in is done. Now you can focus over here. I think it's visible to all of you. This is visible to all of you. Do let me know, everyone. Is it visible? Roshan, yeah, I will. Roshan, I will. With questions. Today is the turn of D block and questions. Roshan, okay? And definitely after this, I will teach you the coordination chemistry, because in coordination chemistry, isomerism, the visualization of isomerism, balance bond theory, each thing I have completed. Only synergic bonding and IUPAC is being left, and some other things like trans effect, simple things which are not given in NCERT, they are missing in NCERT. Those things also I would like to take. But yes, definitely, Sahana, warm welcome, warm welcome, warm welcome. Thank you, kids, thank you. Now see to it, everyone, this is the table which I have taken from NCERT. Science teacher, very crazy man, felt cold in night with cousin. Second year lying AC, टी जरा हाफ, वो नवाब था करोड़ मोल वाला मन टकराए. So in this way, this is period wise. So right now, if we talk about the atomic radii and ionic radii, we should remember these elements. Organic chemistry, Baba, yeah, organic chemistry. Now, every day I'm telling you that organic chemistry, inorganic chemistry, physical chemistry. So this slot is fixed. Just wait. Do let me know. Today I have added one video just before the class. Not just before the class, better to say 2 hours before this class. There I have taken 6 questions of carbonyl compounds. So the same thing I will do over here. I will move question by questions and I will explain the concepts on those questions. Daily I will keep one class of 90 minutes for organic chemistry along with this class. Here I will keep on teaching inorganic or physical. Addition to that, I will always keep every day one class for organic chemistry of at least 1.5 hours or 2 hours, whatever the time is going to be taken for completing those questions. Agreed? And that I will start from most probably from tomorrow or day after tomorrow, right? Harni Singh, you got late. I was waiting for you. Rishi Sonak, Harni Singh, you got late. I don't know why. Anyways, should we start now? Are you ready? Now see. So just right now focus on science teacher, very crazy man. This you have to feed in your brain. Already it's been explained by me. Science teacher, very crazy man. Now, let me tell you one thing very clearly. Just see what I want to tell you. This lies in which group? And this lies in which group? This lies in which group? And that, sorry, not the group, period. Not the group, period. And this lies in which period? So, my dear friends, remember that the filling of configuration, electronic configuration is like n minus 1d. Remember that? N minus 1d. N minus 1d means whatever d is there, that is 1 less than. That means if I say this is 3d, this is 3d. Why it's that much bold? This is 3d. So this is 4th period. This is 4d. So this is 5th period. And this is 5d. So it is 6th period. Clear? That means there are 3 types of D series: 3D, 4D, 5D. Clear to all of you? Again and again I am not going to ask. Once clear, put one green heart that yes, it's clear. Now 3D, 4D, 5D. So the period is 4th, 5th and 6th. Now my dear students, remember one thing very clearly. If we are not having an idea about periodic table, we won't be able to understand this. So let me give an idea about the periodic table, then only you can understand it. So see, just to understand it, we should have an idea about the periodic table. So see, periodic table is like this. Here, everyone, whatever the trick you know, Go with that trick. Helena. Helena. Ki. Ki. Rab. Say. Faryad. That is in Hindi. Leave this. This is a radioactive. In English, I have given you one trick. What is that trick? Lena knows Ruby sis in France. In English, I have given you one trick. Lena knows Ruby sis in France. So the period is like 1, 2, 3, 4, 5, 6, and 7. Now it's here beryllium, magnesium, calcium, strontium, barium, radium. Now, my dear students, remember that where is your science teacher? 4th class ka science teacher, very crazy man, felt cold in night with cousin. Science teacher, very crazy man, felt cold in night with cousin. Now, second year or Skylac, second year लाएंगे AC और Skylac, T zara half, Rafi, whatever the way you remember. Only this much I want to know. Only this much. My focus is only up to here so that I can tell you each and everything. Remember that. Now, whenever you want to have a good command on periodic table, at least bare minimum you should know helium, neon, argon, krypton, xenon, radon. 2, 10, 18, 36, 54, 86. Now, if I talk about the period 1, 2, 3, 4, 5, 6. So see, what should be the atomic number of cesium? If I say cesium, cesium will be how much? 6th period after 5th, 54. So 55, can I write 55? 55, 55, 56, 57. Am I right? And hafnium's atomic number. Is there anyone who knows hafnium's atomic number? Do let me know in the chat section. 72. This is 72. Now, my dear students, what's the problem? This lanthanum is 57 and this hafnium is 72. How many elements are missing? Do let me know how many elements are missing. 14 elements are missing. 14 elements are missing and they are lanthanoids. These 14 elements are lanthanoids. Lanthanoids. And now if I say this is 86, 86, 87, 88, 89, and this is 104. Now, how many elements are missing? So, the answer lies 14 elements are missing and they are actinoids. Actinoids. Now, what actually I want to tell you, my dear students, what actually I want to tell you, just focus over there. The lanthanoids, they are lying in 6th period. 6th period means if I say D, this is your 3D, the first transition series. This is your 4D, the second transition series. And this is your 5D, 6th period, 5D. Is it clear? So the lanthanoid starts from here. Lanthanoid starts from here. Lanthanoids are not there. Remember that. No problem of lanthanoid over here. No problem of lanthanoid over here. Remember that. No problem of lanthanoid over here. No problem of lanthanoid over here. No problem. The problem of lanthanoid will be created from 6th period and after this lanthanum. Is it clear? after lanthanum and 6th period. Is it clear? First of all, do let me know whatever the problem is getting created, that is known as lanthanoid contraction or actinoid contraction, that will start from here, here and here. No problem of lanthanoid contraction and actinoid contraction on this place. Do let me know, are you getting my point? What I'm telling you, kids, everyone, just try to understand what I'm telling you, what I'm trying to teach. I can't see that Josh. Josh is missing, kids. Do let me know, everyone. Today's class is 7 to 9. So I want to see the Josh in the chat section, everyone. Hey, I want to see that Josh. Are you able to understand or not? Only 11 is active. Others are not looking that active. Sahana. Now, my dear students. So this point should be very much clear. Now see, everyone see to it what the problem is. Now let me take this thing on the next page. So what I want to tell you, if I write scandium and I will write titanium over here, second year लाएंगे AC or skylac and T zara half Rafi. Now my dear students, remember that this belongs to 4th period, 5th period. This is about the period 4th period, 5th period, 6th period and 7th period. If I talk about D series, this belongs to 3D, 4D, 4D filling is there, 5D and 6D. Now my dear students, lanthanoids. Now see, its atomic number is how much? 57 and it is 72. This is 90. This is 90. No, 89. 89. This is 89 and that is 104. So the lanthanoids are lying over here. The lanthanoids 14 elements over here and actinoids 14 elements over here, and their atomic number is 58 to 71 and 90 to 103. These are lanthanoid, these are actinoids, and there is no problem of lanthanoid and actinoids. So these are going to form lanthanoid contraction. They are responsible for lanthanoid contraction, and these will be responsible for actinoid contraction. Actinoid contraction. I hope that everyone is able to understand. Now, as we know that as we go down the group, as we move down the group, the size increases. There is increase in size. So if I go down, so see here continuously the size will increase because there is no lanthanoid and actinoid contraction. So see, the size will keep on increasing. Size will keep on increasing. This is smallest in size and this is largest size. Fine, kids. But here, if I talk about where, here it's very important, and keep in your brain, kids, what I'm going to tell you, that holds a hell lot of weightage, Here also the size will increase. Here also the size will increase, but only up to here. Size will increase only up to here. Size will increase, but you know that here is a lanthanoid contraction. So on moving from left to right, size will keep on decreasing. So their size will be approximately same. That means zirconium and hafnium, their size is almost same. How many of you got it? That means 3D The size of 4D is more, but if I talk about 4D and 5D, their size is approximately same. 3D, 4D, 5D, the size is like this. The size is like this. But remember that. Remember, my dear students, except these, except lanthanum and scandium ytterbium, they are also belonging to D block. So people call them to be exceptional case. There is no exception because they are lying before lanthanoid and actinoid. So people call they are exceptional case, but I will not say. So scandium, then ytterbium, then lanthanum, and then actinum. People call these to be exceptional case, but I will say these are genuine things. There is no exception. There is no exception. It has to be like this only. So it's like this only. Can you get it, kids? The size is like this only. There is no exception. Now question arises, why this lanthanoid and actinoid contraction is there? How many of you are really interested in understanding what is the actual reason of lanthanoid and actinoid contraction? Do let me know in the chat section, kids. Everyone do let me know in the chat section what is the actual reason of lanthanoid and actinoid contraction. Sitesh, thank you. If just check it out that each and everything is working. I can't see. If just check it out. Very good. Now it's okay. Now it's good. I'm keeping an eye in each and everything. Okay. Now see, kids. Lanthanoid and actinoid contraction. Just see. First of all, just try to see. If I say the S is what? S is like this, P is like this, D is like this, and F is like this. What is SPDF? Do you remember what is SPDF? S, P, D, F. What do you mean by SPDF? They are subshells. These are being subshells. Now if I talk about S, so S is very dense. The density is too much because they lie in very small space. Electrons are moving in very small space. P is almost near about dense like S, but not that much. It's P is like this. But if I talk about D is like this, diffused. D is diffused. And if I talk about F is super diffused. If I say in today's world, have you seen the clothes? Some clothes are like that. If you're wearing, they are almost translucent. So they are not diffused. Are you getting what I'm trying to say? This is diffused. Diffuse means holes are there. I will talk about it, Sham. I will talk personally, right? Individually, I will let you know. Now, this is diffused. And this is super diffused. What does it mean? If I say, if you consider them to be tree, actually these are subshells. These are subshells. If I consider, let us say they are tree. If I say they are tree, if I consider them to be tree, analogy is giving tree. This is tree. This is also tree. This is also tree. This is also tree. Okay. Now I'm considering your nucleus to be the sun. Nucleus I'm considering as sun. This is sun. I'm considering your nucleus to be equal to what? This is your nucleus, but I'm saying this is sun, 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 the source of ultimate sunlight. So actually this is nucleus. What analogy I'm taking, kids? What analogy I'm taking? I'm saying this is sun. So sun will spread its rays, and if I say Champa is standing under the tree, Champa is, there is Champa, Champa is standing under this tree, Alia is standing under this tree, Malia is standing, Dahlia is standing under this tree, and Phalia is standing under this tree. And it's very hot. Summer season is going on, very hot. Okay, very hot. Or should I say it's very cold? Okay, let me say it's very cold. It's very cold. Winters are around the corner. So winter season is there. I would like to say winters. It's winter time. Now, whom do you think is getting maximum sunlight from the sun? Whom do you think is getting maximum sunlight from the sun? This sun is spreading its rays. This sun is spreading its rays, and all the rays, they are coming on. Let me do the nomenclature. This is X, this is Alia, Balia, Malia, and Kalia. Alia, Balia, Malia, Kalia. So you see this tree, its leaves are not going to stop. It will not be stopping the sunlight. Sunlight will come directly and will fall on Kalia, and Kalia will get attracted towards sunlight because winters are there. So maximum force of attraction is there. Maximum force of attraction. Are you able to understand? Maximum force of attraction is over there. So this is outermost electron. This is outermost electron. So it will go more closer to the nucleus. It will lie more closer to the nucleus. Are you getting my point? Now here also sun rays will be coming, but not like that. But not like that. And there only a piece of, what to say, not the piece, very few rays. So my dear students, whose shape is diffused, which subshell are not able to stop the nuclear force of attraction, or which subshell screening effect is poor, screen are not able to act like a screen. Screen means which is stopping the force, which is stopping the effect. That is the screen. Your window, your door, and the one who is fighting, whatever they are using, just like against the sword, they are shields. Shields whose shielding is poor. Do let me know if you are really able to understand, kids. I can't see anyone's message in the chat section. Are you able to understand? The shielding effect of D and F is very poor. Are you getting my point? Very, very poor shielding effect. D and F is having very, very poor shielding effect. Very, very poor shielding effect. Kids, do let me know. D and F, they are having very, very poor. And this one, F, is having poorest shielding effect. Poorest shielding effect. Poorest shielding effect. And shielding effect is also known as screening effect or screening effect. Screening effect. I hope you got it. And that's why the outermost electron is maximum attracted and the shape is getting contracted. Not the shape, better to say size, because shape is different thing. size is getting contracted, and this is known as lanthanoid contraction. This is responsible for lanthanoid contraction, and this is known as scandite, because d orbital is also having diffuse shape. So these are responsible for scandized, because after scandium, whatever the elements are there, scandite, scandized contraction, and this is known as lanthanoid contraction. Lanthanoid contraction. I hope that everyone got it. Now let me go back to the same thing. If you are really able to understand and try to understand that, see, the thing, let me tell you what elements are they are actually. The lines they have shown. So these lines, actually the color is not visible, but we can correlate the color. So see, this is the size. Can you see this is the size? Upper side more size and downside less size. Can you see? Or lower side is more, upper side is less. Radius in nanometer. These two are lying closer together, and this is lying very much over that side. What inference, what result you can withdraw? Are you able to understand anything or not? No, sir, I am not able to understand. Okay, wait. Let me show you then the theory part. Then try to understand that how many of you are able to understand. See, read it out. Increase in atomic size with increase in atomic number, the net result of the lanthanoid contraction is that the second and third D series, second and third D series, second D series means 4D, 4D means fifth period, and third is sixth period. Okay, got it? So what they are writing, exhibit similar radii, that zirconium and hafnium's radii. Zirconium and hafnium's radii is almost same, and you see it is a little bit 1 point lesser than that. It is 1 point lesser than that. They have very similar physical and chemical properties. That means 4D and 5D, because they are writing second and third D. Second and third D means 2D. No, second D means not 2D. Second D means after 3D. 4D and 5D. 4D and 5D means fifth period and sixth period elements. When we are talking about D after lanthanoid and actinoid, so what we are talking about, that see, already I have told you over here, they are talking about this, that this is your 4D. They are talking about 4D and 5D. Leave this. Their size is almost same, and that's why I have written that 4D and 5D, their size is almost same. How many of you got it? Okay, how many of you got it? How many of you got it? I hope that everyone got it, and that's why it's clear to all of you. Now you can read it out that their size is like this, almost same. How many of you got it? How many it is clear? Clear to all of you now, see kids. Next this, remember that the one, if I talk about D block elements, they are having free electrons. Dhruti, love from Karnataka, Bangalore. Thank you. And Akash Kumar Mishra is asking, sir, please increase your speed. Okay, sure. Pakka. Okay. But I wanted to tell you the D block, because without understanding the lanthanoid contraction, you won't be able to understand anything. That's why I told you lanthanoid contraction in detail. Okay, now see, D block elements are having free electrons. Do you think all D block elements are having free electrons? No. Zinc, cadmium and mercury, they are having fully filled configurations. So zinc, cadmium and mercury, they are not having any unpaired electron. The unpaired electrons are responsible for metallic bonding. Metallic bonding means that is getting strength. But zinc, cadmium and mercury, they are not having any unpaired electrons, so they are not able to form metallic bond. So their melting point will be lowest. Who is having maximum unpaired electron? That is chromium, molybdenum, tungsten. Am I right? Chromium, molybdenum, tungsten, they are having maximum number of free electrons. Why? If I talk about chromium, chromium's atomic number is 24. 24 means 3d54s1, d5 and s1. They are having many free electrons, maximum free electrons. Chromium, molybdenum, tungsten. Because of maximum number of free electrons, they will form very good metallic bond. Very good metallic bond means melting point will be maximum. This is very, very Sahana. Baba, pin the telegram. Oh, my team has forgotten. My team has forgotten. If and everyone, the rest of the students, can you send message to my team so that they can pin the telegram link? Okay, now see, chromium, molybdenum and tungsten, the melting point is increasing. Melting point is increasing. So who is having maximum melting point? Chromium, molybdenum and tungsten. And if you see copper, silver, gold, they are over here. Zinc, cadmium, mercury, they are out of the picture. Can you see? Zinc, cadmium, mercury, they are out of the picture. Can you see, kids? Zinc, cadmium, mercury, they are not in the picture because zinc, cadmium, mercury, they are not having any unpaired electron. The transition metals with the exception, zinc, cadmium, mercury, zini Canada hogi are very much hard and have low volatility. Their melting and boiling points are high, right? Is this point clear to all of you? Is this point clear to all of you? Yes, sir. We got it. Now, next. Just see next point. Next point, very, very important point. That is on the this. This you should know from the electrochemistry. The standard reduction potential, the element which is stable in its native form, and if you are provided with the cation, so it can easily accept electrons. So SRP value is positive. If you know the electrochemical series, how many elements are lying below hydrogen in the electrochemical series? How many elements? Just see, if I talk about below hydrogen, how many elements are there? I would like to say these are the elements. That means if I say that Cu2 plus will easily accept electron, and will convert into Cu solid. Same if I talk about this, same if I talk about this, same if I talk about it, same if I talk about it. So if I say Hg2 plus will accept electron, Ag plus will accept electron, palladium 2 plus will accept electron, Au3 plus will accept electron. That means its SRP value is maximum, and it is also having SRP value positive. This you must have studied in electrochemistry. Rest of the elements, they are not going to accept electron. So these are very good oxidizing agent, and their oxidizing nature increases down the group. The power to accept electrons increases. Is it clear to all of you? And they will not give, if I say that will they donate electron? No, their tendency to donate electron is negative tendency to donate electron. They have got negative tendency to donate electron. I hope this point is clear to all of you. Is it clear? Do let me know in the chat section. Kids, keep on showing green hearts. Metallic bonding. Okay, Akash Kumar, let me show you the metallic bonding. As Akash Kumar is asking for metallic bonding, just see, just have a focus over here. Akash Kumar, see the metallic bonding. If I talk about the metallic bonding, just see to it. Just focus over here. That if I say that chromium, scandium, science teacher, very crazy man. And if I write zinc over here, right? Now if you see scandium, atomic number is 21. So if I write down that, just reverse it, 1 and 2. So 3d1 and 4s2. So in D there is one unpaired electron. Titanium 22, 3d2, 4s2, 2 electrons in D. If I write down about chromium, chromium is having 3d5, 4s1. How many unpaired electron? 5 over here, 1 over here. If I write down manganese, 3d5, 4s2. If I write down zinc, zinc is 3d10, 4s2. No unpaired electron. No unpaired electron means what? Let me explain about chromium. So chromium's nucleus will be like this. In the nucleus there will be how many protons? 24 protons. And its nucleus, this is the nucleus of chromium. And let me take one more nucleus of chromium. There will be many chromium and there will be many electrons. Now this is considered, this is Raja. This is Raja, and Raja will have many Ranis. And that Raja, that Raja will be having many Ranis. Now this Raja is attracting its own Rani, but at the same time, this Raja is attracting this Rani also. And same over there, that Raja is having force of attraction on his own Rani, but at the same time, that Raja is having attraction on other Raja's Rani. So they are due to Raja and Rani. Raja Rani ki kahani ye purani 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 ho gayi. So due to this Raja Rani interaction, they are lying very close to each other. Even if you provide some temperature heat, they will not move away so fast because of Raja Rani interaction. But these free electrons are required, unpaired electrons are required. Then only this force of attraction will be there. And due to this force of attraction, metallic bonding is there. I hope you got it, Akash. I hope you got it. Everyone got it. Everyone. So the number of unpaired electrons is increasing, and that's why metallic bonding is increasing, and that's why chromium is having maximum melting point in its period, then molybdenum and then tungsten in their respective period. Got it, kids? Do let me know. Everyone got it? Yes sir, we got it. Now this from electrochemistry, you know very well that an examination of this table, I will show you the table. And due to T2G and EG, I have already explained yesterday in D block, already explained T2G and EG, what is the role. Now trend stability of higher oxidation state. Wow, this is very, very important point. This is really very, very important point, and no one is teaching this point. Now this year, NTA will frame out question from here only. NTA will definitely frame out question from here only. See, we know that. Let me tell you from on separate page so that you can understand this. On separate page so that you can understand it. If I say that manganese maximum oxidation state is how much? Highest oxidation state. Do let me know in the chat section, everyone. Highest oxidation state. Manganese highest oxidation state is +7. +7. That means it has donated electron. It has donated electron. What do you think? Everyone is having this much of capacity to eliminate out, to take out 7 electrons. Just wait for a second. Let me bring one more marker. Okay, just a second. curve. Now, sec its highest oxidation state is +7. So this is undergoing oxidation. This is undergoing oxidation. Now, manganese is in need of stable electronic configuration. Stable electronic configuration. Right now, its configuration is, better to say, equivalent to argon, a noble gas configuration, right? Now, do you think that this manganese, just to gain stability, will give electron to everyone? Do you think? While giving its Dhruti, sir, should I follow these lectures for D block or a Phoenix? I'm teaching from the scratch. Dhruti, I'm teaching from the scratch, and every day I will give the best one, the best thing. So you have to follow over here, right? If you have faith on me, Baba will complete each and everything, right? I will take daily 3 classes, right? Now, do you think this manganese, this is a reducing agent? It's a reducing agent, right? And do you think that this manganese will give electron to everyone? The answer is no, no, a big no. In return of giving electron, electron is like money. I've told you, electron is like, electron, I've told you, it's equivalent to money. If somebody is giving money to somebody else, if somebody is giving money to somebody else, because there should be oxidizing agent, this is half reaction, half, so its better half must be there. So if I say this manganese is a man, if this manganese is a man, and this man has given money to somebody else, that should be the better half of this manganese. Very good, Mike. Cool tube. Very good suggestion. This man manganese will give electron to its better half, and that better half should provide what to him? Sarthak, thank you. That better half should provide, that should love him, the loving one. The better half must be loving one with both the hands. Visham, thank you. That loving one must provide stability with both the hands. Hug him. Now if I say there is one Florida, there is one Florida, she is single-handed, having only one hand. Florida is fluorine. Don't take it personal. Don't take it personal. Florida is fluorine. You will be able to understand. Just follow. Just see to it. And if I say there is another girl, its name is Oxy. Its name is Oxy. She is having 2 hands. She is having 2 hands. Oxy means oxygen. Now do let me know, this fluorine will provide more stability to this man, or oxygen will provide? Both will snatch electrons. Both will snatch electrons. But who will provide more stability? If I say that if manganese is giving electron to this Florida, it will form MnF7. And if it is giving electron to this oxygen, it will form Mn2O7. Now tell me which one should provide more stability. This is forming double bond. It is forming double bond, and that is forming single bond. You tell me, kids, you. I'm not going to tell anything. You just tell me. Sohun. Yeah, Sohun, you're right. That's why I'm telling you, from tomorrow or day after tomorrow, I will take 3 lectures. Sohun, you are right. Sarthak, yes. Now tell me, kids, from tomorrow or day after tomorrow, I will take 3 classes: physical chemistry, organic chemistry, and inorganic chemistry. But you have to be regular. So, Hun, tell me, you will be regular. I will complete whole syllabus and I will put the strategy. Yes, Sarthak, you are right. Now, see. So this will not be possible because it is not providing stability. It is not providing that stability, and this will be possible because it is forming double covalent bond. So maximum oxidation state is shown by oxides. It's not shown by fluorides. Got it? How are you getting? And let me show you this simple thing. This is happening in everyday life. I have given one example from everyday life. Have you ever seen this example from everyday life? Example I took from everyday life. Do let me know, kids. Have you ever seen? Now let me show you this thing. Let me show you this thing over here. Just see. Trends in stability of higher oxidation state. This is very, very important point. Very, very important. Now see. The highest oxidation number are achieved in halides, only VF5. Fluorine can snatch all the 5 electrons from vanadium, but it's not with everyone. Not everyone. Now see, the +7 oxidation state for manganese is not represented in simple halides, but MnO3F. See, 3 oxygen and 1 fluorine is there. Not only the fluorine cannot form, fluorine can just form 3. Now the stability of fluorine, the stability of fluorine to stabilize the highest oxidation state is due to either higher lattice energy. Point to be noted, my lord. It's due to higher lattice energy. What's the reason they are giving? Higher lattice energy if they are going to form, then because of higher lattice energy. But everywhere they are not going to stabilize, as in the case of COF3 or vanadium fluoride, but very rare, very rare. Now my dear students, see, oxygen, where oxygen has gone. They have given information about oxygen. The other halides, however, undergo hydrolysis to form oxyhalide, but where they are forming about, okay, I will come to that, either because of higher lattice energy or a higher bond enthalpy. So if anybody is asking why vanadium pentafluoride is formed, if fluorine are not able to stabilize, then what's the reason on what we have vanadium pentafluoride has been formed? Thank you, Dhruti. Thank you. How vanadium pentafluoride has been formed? So the reason, remember that one is higher lattice energy or higher bond enthalpy. Now let's talk about oxygen. Where oxygen, they are talking about oxygen. I think here oxygen, where the oxygen has gone. So let me find it out in NCERT because I can't see over here. It's missing over here. Just wait. Just wait. I will show you. It was missing in this PDF, right? Let me show you. See the colors they are given. I will come to this. Colorful, it's given over here. You see over here. Is it visible to all of you? Is it visible to all of you? The element with the greatest number of oxidation state occurring in the middle of this and this lesser with this few electrons, and where they have given about the oxygen, just see, yes. An interesting feature in the variable oxidation of D block element, this oxidation not given over here, not given over here, not given over here. Trends are given over here. Higher oxidation states, the trends, this trends in stability of higher oxidation state. Now see kids, see where they have given about oxygen. Here also they are, although this is oxyhalides, oxyhalide, copper, this I will come because it is very, very important, but I am thinking about, yeah, it's given over here. See. Now see, this is my concern. The ability of oxygen to stabilize the highest oxidation state. I am coming to this point. Are you ready? Just try to understand, everyone, what I am going to tell you. Just focus, kids. Just focus. Oh, it has gone. Let me shift it a little bit downside because it's given over there. I have to talk about this. The stability of oxygen to stabilize. So wait. Yes. Now see kids. Now see. This point noted, my lord. Focus over here. The ability of oxygen to stabilize the highest oxidation state. The highest oxidation state. The highest oxidation number in the oxides coincides with the group number. This is the point to be noted, my lord. This point I want to focus. This is the important point. They were said that only vanadium fluoride was formed with maximum oxidation state. Vanadium's electron, even chloride, bromide and iodide, they are not able to snatch. Only fluoride has snatched. If I talk about manganese, it's all the 7 electrons can't be snatched by fluoride. Man's MnF7 is not possible. But they are saying the maximum oxidation state that is equal to its group number. That means if I talk about chromium, chromium's group number is 6th. So Cr2O3 is possible. Manganese group number is 7. So Mn2O7 is possible because oxygen will stabilize. Why oxygen is able to stabilize? The question's answer is given over here. Just see. Beyond group 7, no higher oxide of this, and reason, where the reason is given, where they have given the reason. The ability of oxygen to stabilize these highest oxidation state, the ability of oxygen to stabilize higher oxidation state exceeds that of fluorine, exceeds that of fluorine. Just see. The ability of oxygen to stabilize these high oxidation states exceeds that of fluorine. You got my point? How many of you are able to understand? Shyam, thank you. Do let me know how many of you are able to understand. Shall be seeing. Iffy, 11, Shyam, Dhruti. Have you ever studied this thing, that the ability of oxygen to stabilize these high oxidation state exceeds that of fluorine? The same point of the story I have shared. The story I told you, it's given over here. Thus, the highest manganese fluoride, the highest manganese fluoride is MnF4, only MnF4, neither MnF5 nor MnF6 nor MnF7. How many of you are able to understand, kids? Surya Buddha, hey everyone, right? down. How many really, have you ever seen this NCERT like this, in this way? Yesterday I taught you potassium dichromate, KMnO4, their preparation and chemical reactions. Today I'm teaching this D block NCERT is this thing. Have you ever seen like this thing in this way? I want to ask with you kids, do let me know, have you ever seen this way of studying? And the story of fluoride and oxy I taught you right now. So see, whereas the highest oxidation state of oxide, whereas the highest oxidation of oxide is Mn2O7, the simple thing I've told you. And what's the reason? I am coming, the reason. The fluoride was forming because of high lattice energy or bond formation, but oxygen is forming, the ability of oxygen to form multiple bonds to metals explains its superiority, my kids, superiority, because oxygen can form double bond. If somebody is falling from the hill, if you're shaking one hand, if you're trying to pull that candidate with one hand and somebody is holding with two hands, who will provide more stability? Do let me know in the chat section. One is just pulling with one hand like fluorine. One is pulling with both the two hands. Both are pulling, both are applying force. But who is providing more stability? Oxygen. Oxygen is pulling with both the two hands. Fluorine is pulling just from one hand. Hey everyone, do let me know you got it. And in the covalent oxide like this. Got it. And that is the story. This is the story. Already I taught you over here. I've shown you the story. You see the story I taught you over here. This was fluorine and this was oxygen. So oxygen is able to form Mn2O7, whereas fluorine is not able to form MnF7. No need to cram. Cramming mana hai, ratna mana hai, just samjho. Try to understand. I hope that everyone is able to understand. Now let me go back to the same thing. Where? Just wait, because copper one is very, very important. Now, copper one. Now, if I ask one question, simple question. If I ask one simple question to you kids, that copper's atomic number, copper stability, let me write down the heading, stability of copper, stability. Now, if I ask you, my dear students, copper atomic number is 29, exceptional configuration 3d10, 4s1. So, do let me know who is more stable. What do you think? Cu2 plus is more stable, or Cu single plus is more stable? Which one is more stable? Do let me know kids. This versus this, and we are comparing the stability. Which one is more stable? Tell me. Cupric is more stable. Do let me know your answer in the chat. Cupric is more stable or cuprous is more stable? Which one is more stable? I want to see your answer in the chat section. According to you, out of these two, which one is more stable? Question is, which one is more stable? Cuprous or cupric? Shalvi Singh is saying cuprous. Let me have a sip of water. The question is, cupric is more stable or cuprous is more stable? Everyone, do let me know what's your answer. Speedily. Do let me know. Fast, kids, fast. I want to see the answer in the chat section. Who is going to answer it clearly? Who is being more stable? Cuprous or cupric? Now, my dear students, everyone's answer is wrong. Everyone's answer is wrong. Why everyone's answer is wrong? If I ask you one question, that what do you think? Who is more powerful? A shark or champa? Who is more powerful? Do let me know who is more powerful. A champa is a girl. Champa is a girl. And shark, you know very well, Champa is a girl, and shark, you know very well, shark is a giant fish. Who is more powerful? Do let me know. Who is more powerful? Or if I say there is one lion is there, and one elephant is there, or crocodile is there, who is more powerful? Who is more powerful? Either you can give answer between lion, crocodile, you can answer between Champa, shark, or you can answer between cupric and cuprous. Do let me know, everyone. This is X example, this is Y example, this is being Y example, and this is being Z example. Anything you can tell me. Depends on the medium. Now you got the answer. If shark is inside the water, then shark is powerful and Champa is getting defeated. If crocodile is inside the water, then lion will not be powerful. That crocodile is more powerful. But once the shark is on the land, Champa will become more powerful. Once the crocodile is on the land, the lion will become more powerful. So it all depends the medium. Am I right, kids? The water, story of water, whether they are inside the water or they are on the land. Are you getting my point? So the whole story is all about whether they are in water or they are on land. Medium is very, very important. You are getting my point. No need to do rectification. Medium plays a very, very important role. Medium plays a very, very important role. So whether they are in water, water is aqueous, or they are on land, they are on land, that is solid. Solid on land, they are being solid. Crystal, they are being solution. Now, are you getting my point? Are you getting my point? So now you are able to understand. Shall we sing? You are getting that. If I say that water is like a mother, water is like a mother, like a mother, mother, mother. Now mother loves whom? Mother loves both the smaller one and the bigger one, elder one. But mother's love is always more towards the smaller one. Mother's love is more towards the smaller one. So hydration is inversely proportional to size and directly proportional to charge. Charge is like the sun is crying. How much sun is crying, suffering in life? What is the charge? Charge is like crying, Cu2 plus, and size is like how much big he is. So you know very well that Cu2 plus has donated 2 electron and Cu plus has donated 1 electron. So Cu2 plus is smaller in size. So mother's love will be maximum for cupric, and mother will stabilize cupric. Mother will come from all the side, means water will come from all the side, and water is coming nearest. Maximum water molecules are coming nearest to the this copper cupric. Maximum water molecules will come. All the water molecules will come from all the side. Water molecules will come from all the side. And when somebody is coming closer, they are releasing energy. They are releasing energy, that is exothermic reaction. The energy keeps on decreasing. They are emitting out energy. Delta H is negative, 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 negative. Highly exothermic reaction. So energy is decreasing. Energy is decreasing, 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 and stability is Hey bachcha log, do let me know. Stability is increasing, 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 increasing. Now, near to the copper, it is having less charge, more size. Water molecules will come. Water molecules will come, but not so many water molecules. Only few water molecules will come. So its hydration energy will be negative, but not that much. So who is more stable in water? Cupric is more stable. Wow. Cupric plus is smaller than copper. Yes, because it has donated 2 electrons. See, it has donated 2 electrons. You know that in between electron and electron, there will be repulsion. In between Rani and Rani, there is force of repulsion. And in between Raja and Rani, there is force of attraction. So Ranis are less. Ranis are less, so repulsion is less, attraction is more, so size decreases, Z effective increases. Are you getting my point? Everything is correlated. Z effective increases. Every atom is having nucleus. In the nucleus, inside the nucleus, there is proton that is having positive charge, and that positive charge is applying force on all the electrons. And electron, they are negative charge. There is repulsion in every atom. There is all simultaneously there is force of attraction as well as force of repulsion. So remember that in case of same atom, the protons are remaining 29 only. 29 only. So the force of attraction given by the proton is like that only, but repulsion, where repulsion is less, because here electrons are less, so repulsion is less, so attraction is more. Are you getting my point? Sabrina Madhumudha, I'm following you for a long time, sir. I'm your big fan, sir. 2 words in Tamil, please. Tamil. People say that right now I'm going to speak Tamil because one student has just asked for it. Chemistry pidikya radu customer. Chemistry pidikya radu customer. Elle, it's romba sulbham. Idiyappam murku things will become romba sulbham. Medhuba. What I said in Tamil. Those who are thinking chemistry is tough, I'm saying no, it's not tough. It's easy. The confusing things, the tough things, I will make them to be super easy. Slowly, gradually. Am I right? Am I right? Whatever I have spoken, that was perfect. That was perfect, kids. Do let me know in the chat section. Now, so what we are getting, that cupric is more stable in water. Cu2 plus is more stable in water. So in water, Cu2 plus is more stable. So in solid state, who will be more stable? Definitely in solid state. In solid state, Cu2, Cu single plus is more stable in solid state. Now let's see whatever I have told you. Let me show you the same thing in the NCERT. Just see. Is it visible to all of you? However, many copper compounds are unstable in aqueous solution and undergoes disproportionation. Do you think Cu plus is stable in water? Do you think Cu plus is stable in water? Everyone just to let me know, do you think that Cu plus is stable in water? Do you think that Cu plus stable in water? Everyone, Baba is asking one thing. Do let me know. Do you think that Cu plus stable in water? Answer is big no. Cu plus is unstable. It is unstable. It is unstable. So definitely what will happen? Cu plus will try to convert into Cu2 plus. Now is it okay? The screen is okay. Do let me know. Now the screen, can you see? Visibility is clear. Visibility is clear or not? Now do let me know. The visibility is there. Can you see the screen? Do let me know, kids. Can you see the screen? Hey everyone, bacha log. Hey my dear kids. Everyone just do let me know. Now is it okay? Is it visible to all of you? Okay. So Cu plus is not stable in water. So it will convert into Cu2 plus, from where it will give electron. It will give electron as well as it will accept electron. So one copper will donate and one copper will accept. So one copper is donating electron, not able to understand, sir. See, if I say one copper plus is donating one electron, so it is becoming 2 plus and it has given one electron. So a reaction, half reaction is never possible. Yeah, when I go near to dark. Yes, yes. Thank you. So do you think a single reaction where only reducing agent is there, that is possible? Not possible. So for a reaction to take place, there should be reducing agent as well as oxidizing agent. So Cu is donating electron, Cu plus is donating electron. So cuprous is changing to cupric. Now who will accept the electron? In water, nobody else is there. And water is saying, I'm not interested in any electron. Your business is your business. That's none of my business. So in water, who will accept electron? So only Cu plus is the one who will accept electron. So Cu has donated and another Cu will accept that electron, this electron, and when convert into Cu solid. So this reaction is like that. 2 Cu, one is undergoing oxidation, another one is undergoing reduction, and this is known as disproportionation reaction. I hope that everyone got it, what I taught you. It's not like that how much we have completed. Never see that how much we have completed. Always first see what quality we have got. Everyone is getting good quality or not. Everyone is getting just like, oh my God, it's really very crystal and clear. Now see the reason. The stability of Cu2 plus aqueous rather than Cu plus aqueous is due to much more negative hydration energy. Already I've told you, already it's been explained by your Baba. And then Cu, now of Cu this is completed, which is more than compensated for the second ionization energy of this. Now my dear friends, there are two things taking place. That one, if you want to convert Cu plus to Cu2 plus, you have to supply ionization energy. So to convert Cu plus to Cu2 plus, you have to give energy. That is the minimum amount of energy required to remove one electron from the outermost orbit of an isolated gaseous atom. It is known as ionization energy. So if you want to convert Cu plus to Cu2 plus, let me tell you what I'm talking about. Let me write down, otherwise you won't be able to understand. Let me write down, otherwise you won't be able to understand. See what I'm telling you, that you are having Cu plus and you want to convert it into Cu2 plus aqueous. What you're supposed to do, first you have to provide energy that is known as ionization energy. It will become Cu2 plus. Now you have to add water to it. Now two-step process, first step, second step, and the sum of both the two steps should come out negative. Delta G, that is known as Gibbs-Helmholtz equation, delta H minus T delta S. Now see, they all are in aqueous. Nobody is gaseous, nobody is gaseous. So delta S is approximately the change in entropy is 0. So the whole magnitude has become 0. So only delta G is decided by delta H. So whose delta H is coming more negative, the reaction will be more in the forward direction. Now, this is the energy required. So I would like to say this energy is positive energy required, and this is the energy, hydration energy, known as hydration energy, is negative. It is being negative. So what do you think, for a process to take place, which should dominate? The first one should dominate or the second one should dominate? If I say that if this is plus 30 joule, let us suppose plus 30 joule, then that should be minus 30 joule, minus 29 joule, or should be more than 30. So definitely it should be like minus 31, minus 41, minus 50, minus 64. It can be like this. Then see, minus and plus, that will come out to be negative. So this should be more, and that they are saying that simultaneously the energy is required as well as released, but the released one is more than required. Renu Chawla is writing, hi Baba, I am your big fan. I'm your, oh, that's really awesome. Wow, thank you, thank you, thank you, Renu Chawla. Wow. See, kids, huge round of applause to Renu Chawla. Thank you, thank you, really awesome. Great. Now, my dear students, is it clear to all of you? Is this point clear to all of you? Got it? Have you got it? Now it's a time for starting all the questions. Ready for the questions? Everyone ready for the questions? Because I've taught each and everything. So it's a time for the questions. I've gone through each and everything. I have explained each and everything. So it's a time for questions. Let's see how many of you can do the questions. Here are the questions. So I hope that it is visible to all of you. The visibility is proper. Do let me know in the chat section. Is the visibility proper, kids? We are going to start with first question. Let me check it out. Oh, it's looking very small. Wait, kids, wait. Now see, I think now is it clear? Very much clear to all of you. Do let me know this question. Proper visible. Do let me know what should be the answer of first question. Then I will explain. I think the visibility is very proper, kids. Do let me know the answer in the chat. Speedily, kids. Let's make it very speed round. Let me have a sip of water and meanwhile try to answer the question. Let's see who can answer it, kids. Who can answer it? What's the answer? D. 11 is going for D. So D is the correct answer. Absolutely correct. This is the correct answer. Incompletely filled N minus D subshell in ground state or any of its oxidation state. The transition element is defined as one of the incompletely filled. So from this first point, what result you are getting? This fourth point is telling you one thing, that will you think that zinc, cadmium and mercury are zinc, cadmium, mercury, they are having unfilled, incompletely filled? No. So they are not treated as what? Not treated as transition elements, not treated as transition elements. Am I clear? Am I clear? They are not treated as transition elements. So is it clear? Do let me know. Don't forget to show me green hearts if the concept clarity is there. If it is not there, show me fire. If it is not there, I want to see fire. Now, second question. Keep on showing the green hearts if the concept clarity is there, kids. Now, let's go for second question. Second question. Just see the second question. Everyone is not following the rules and regulations. That's very bad thing, kids. If the concept is clear, the explanation is clear up to the mark, then green symbol, either hearts or leaves or trees, any green signal. And if it is not clear, fire, simply fire. B, one kid is going for 7, 8, 8 is going for B. 11, 11 is also going for B. So let's see what's the answer of second, B. People are going for this. Zinc, cadmium, mercury are not regarded as transition element on the basis of electronic configuration because you are saying that D and S subshell remain fully filled in ground and higher oxidation state. No, this is wrong. This is wrong. Let me tell you why. You got trapped. You got trapped. This is wrong. In highest oxidation state, you can see I have taught you right now. If I say Zn, atomic number 30, it is 3d10 and 4s2. Now, if I write down Zn2 plus, then 3d10 but 4s0, this is not filled. What they have written, in the highest oxidation state, the D and F subshell remains fully filled. S doesn't remain fully filled. You got trapped. You got negative marks. That's why I'm telling you, consider it. This is the wrong answer. Then which one should be the correct answer? Let me check it out. That subshell remain incomplete in ground and ionic. This is also wrong. That is also wrong. So their penultimate. Penultimate means next to outermost. If I talk about 4s, then 3d is penultimate. 3d is penultimate. 3d. Second last. Shall remain incompletely filled in ground and in higher oxidation state. Let me check it out. No, not 3d, not 3d, not 3d. Sorry, that is ultimate. Ultimate. Penultimate means n-2, not n-1. Wrong. Wrong. This is wrong. See, if I say outermost is known as ultimate. Outermost is outermost. Next to outermost, next to outermost, next to outermost is known as ultimate. Ultimate. And next to that is known as penultimate. First of all, if I say this is the nucleus, and if it is having number of orbits, so which one is outermost? This is outermost. Which is ultimate? This is and which is penultimate? This is penultimate. You got it? First of all, do let me know. Everyone, is it clear? n-2. Yes, 11, 11. Now you got it. n-2. n-2. Their penultimate shell remains completely filled in ground and in higher. That's correct. This is correct. Remember that. It's very, very good question. And remember that penultimate means n-2. How was the question? My dear students, in the examination, 99.9% people will get failed in this question. Am I right or not? This question is very, very good question. I will give a star to this question. Big star, because it is very, very good question. Am I right, kids? Am I making a sense? Am I right or not? This is really awesome question. Really awesome. Wonderful question. This is really wonderful question. Next question. Now here is another question. Third question. Just see what should be the answer of this question. Third question, everyone. General configuration for D block. Wait. Let me write down. Now, how will you write down? While filling and while eliminating. One thing is during filling, one thing is during eliminating. Are you getting my point? So while filling, you have to go like this. While filling of electrons, 4s or ns2 n minus 1d 0 to 10. But here also it can be in palladium, exceptional configurations are there, so it can also range from 0 to 2. That's very, very important. Now remember that generally it is 2, but in exceptional configuration like copper, chromium, it is 1, and there is one element whose palladium, that is Pandeyji, palladium, there is S value is 0 electron. This is very, very important. It holds a whole lot of weightage. This configuration is $1 million configuration. Remember that, it's very, very important. Now, where were we? We were over here on this question. Do let me know what's the answer. Everyone, I want to see the answer in the chat section. Fast. Jyoti, today you got late. Jyoti, today you got late, na? A little bit late. No problem. Do let me know what's the answer for this question. Fast gets fast. B, 788. Your answer is absolutely correct. B, melting point is directly proportional to number of valence electrons. This already I taught you. More the number of free electrons, more will be the melting point. So it was chromium, molybdenum and tungsten. Tungsten shape is like, if you see, the tungsten shape is matching with what? It's getting matched with your bulb. Your bulb is like this, bulb, and bulb is having filament of tungsten only. Bulb is having filament of tungsten. Tungsten maximum or highest melting point. It is having highest melting point. Got it? Because of the unpaired electron. Yeah, okay, no problem. Now next question. Now I think, let me make it bigger screen. Let me make it more bigger. Yeah, now you can see question number 4. Question number 4. Fourth. Fast, gets fast. Speedily, do let me know the answer. 4th. Speedily increase the speed. Make it to be moving with speed of 100 kilometers per hour. In the series scandium to zinc, the enthalpy of atomization. Oh, remember that this is almost near to melting point, not exactly melting point. Wow, very good. 768, no, 788, 11. Wow, absolutely correct. No 3D orbital involved in metallic bonding. The series enthalpy lowest because no 3D orbital is involved in metallic bonding. Yes. Now, 5th one. What's the answer of 5th one? 5th question. Do let me know. What's the answer of fifth question? Fast. Yes. That was very simple question. That was simplest question. That was simplest one. You could have solved it easily. Now tell me what's the answer of fifth. Fifth question. Fifth, people are, some are going for fourth, some are going for one. Fifth question, everyone do let me know. So its answer will be, so this is closely written, magnesium, which of the following order of second ionization potential? Second ionization potential. So if I say manganese already has donated one electron, so it's, they are talking about that already donated one electron, so 3d5 4s1, it has to go electron from s is far away from the nucleus, and chromium second they are talking about, so already 3d5 4s, so chromium, if I talk about chromium, so it is from D, it has to go from D, and it is 0. It is wrong because it should be like this, so this can't be the answer. Now zinc, they are talking about second, zinc and copper. Copper's atomic number is 29, 3d10 4s1, already it has lost, so it is in state of 3d10, so it is also wrong. It should be like this. These two are wrong. These two are wrong. Are you getting my point? Everyone, are you getting my point? These two are absolutely wrong. Now tell me what should be the answer. Now it's a time for sodium and copper. Sodium's atomic number is 11. Already it has lost one electron, so definitely it is having configuration of 2 8, and there it is having 2 8, so arrow should be like this. Fourth is also wrong. Only one answer is correct. That should be your answer. Third answer is correct. Third one. This was really nice question. Nice question, kids. Nice. Very good question, I would like to say. Very, very good question. Are you getting my point? No, fourth is wrong. Third is the correct. 11. See, it's very clear. Already potassium has lost one electron. Second ionization potential means what? Second means one electron has been lost already. Now tell me the another electron, means first has been lost already. Now they are eliminating out the second electron. So the one who is having this question is really awesome. You are enjoying or not? This will change your life. Once again, 99% students will get failed for this question. 99%. Now another one, the sixth one. What's the answer of this sixth question? Do let me know. Try for this sixth question. Sixth one. Everyone. Let's see who is going to get the correct answer. Fast. Thank you, 788. Thank you. Fast, kids, fast. Only 15 minutes are left. We have to complete it just in 15 minutes. Fast, kids, fast. I want to see the answer speedily. A, very good. 11. A is the correct answer. Which among the following statement regarding ionization potential is incorrect? I think those who have not seen incorrect. Ionization potential of manganese is greater than its IP2. Let's see manganese. Let me write down manganese. Manganese is 25. So I would like to say 3d5 4s2. Now first electron, if you are going to eliminate out, you are supposed to eliminate it from S. Now it will have 3d5 4s1. Now the second electron you want to eliminate, it will form Mn2 plus 3d5 4s0. Now you see, this is having half filled stability. Why it is having half filled stability? Yesterday I taught you T2G and EG. Do you remember? T2G and EG, that is having half filled stability. If you remember, yesterday I taught you half filled stability. So this is more stable, more stable, more stable. This is being more stable. Are you getting my point? So definitely ionization potential of manganese IP1 is greater than IP2. IP1 is greater than IP2. Which among the following statement regarding IP is incorrect? What do you think? IP1. Now, according to this, if you see, this is anaconda question. Let me tell you, this is the anaconda question. Almost all intelligent people will get failed. Almost all intelligent people will get failed. Should I tell you why? Should I tell you why? Should I tell you why? Because they will go for second. They will definitely go for second. And now should I tell you second will not be the answer, first will be the answer? Should I tell you why, kids? How many of you are interested? How many of you are interested? Now they will see that from here to here, this is becoming more stable. So this should be less. But remember that here number of electrons is equal to number of protons. But here electrons are less, protons are 25, but electrons are just 23. So second ionization potential will always be greater than first ionization potential. Second can never be less than the first. The jump can be less or more, but the second IP can't be less than the first IP. Got it? Got it, kids? How was the question? How was the question? It was a really awesome question. I would like to say it's an anaconda question. Anaconda. Anaconda means number of people will get trapped over here. Now, another question. Is it visible to all of you kids? Question number 7th. 7th question. 7th question. Just do let me know. 7th question. This question, do let me know, kids. This one. Fast. 7th. Increase the speed. In anaconda means everyone will try, but maximum people will get failed. Everyone will try this question, but maximum people will get failed. B. 11 is going for B. 7th. Most common oxidation state are matched below which elements, which one is mismatched. Remember that, mismatched. Iron 2 and 3, right? True. Chromium, oh, it's wrong. Chromium is wrong. It should be 3 or like that. So this is the correct answer. Simple question. I would like to say it's being simplest one. Simple question. Now 8th one. Do the 8th one. 8th one. Everyone. 8th one. 8th one. I think you are giving answer for 8th one or the 7th one. 8th one or 7th one. Do let me know. Fast, fast, kids, fast, fast. B. 4th. Okay, let me check it out. Which among the following statement is incorrect? Always read it out, read it out, read it out, my dear students. Focus on incorrect. Incorrect. Now, people are going for 4th. In a group of D block, higher oxidation states are favored by the lighter member. What does it mean, 4th? What does it mean, 4th? Let me check it. Okay. Incorrect. Okay. So incorrect. Even I was thinking for correct. See, even I thought that how this can be the answer. I thought for correct. In a group of D block, higher oxidation state favored by the lighter member. No, it's wrong. Higher oxidation state are given by chromium, manganese. They are not lighter element. So this is wrong and this is the correct answer. Now next. Ninth one, ninth question. Ninth one. Everyone do let me know ninth question. Just do let me know ninth question. Ninth. Fast kids, fast. 788 is going for this. My cool tube is going for 3. Let me check it out. What other students are going for? Kids, this is your, just consider like your exam. Your final examination is going on. 11 is going for A. So A is ticked, C is ticked, D is ticked. That means this question is tough question. I would like to say it is tough because you are going for different answers. So let me check it out. What should be the correct answer of this? Right? Which among the following order of oxidizing character? Oxidizing character means power to undergo reduction. Oxidizing means power to undergo reduction. They are talking about power to undergo reduction. Now, CrO3 plus 6 molybdenum. Okay. Now, my dear students, this is a really very important thing. Let me tell you first and why you missed it, because I haven't taught you. No, it's not an anaconda question. I haven't taught you. That's why it has become anaconda question. I haven't taught you. If I would have taught you, then it's not an anaconda question. Let me tell you. Actually, I teach this during redox. I teach this during redox that the oxidation state is stability, chromium plus 6, molybdenum plus 6 and tungsten plus 6. This is given in your NCERT. If you read NCERT, the stability of oxidation state is like this. Stability increases down the group. This is given in NCERT that their oxides stability increases down the group. Should I show you? Their oxides, their stability of oxidation state increases down the group. But if the stability is increasing down, should I show you? Tell me, or will you search it in the NCERT? It is given. Now, so stability is increasing. So this is more stable. This is being more stable. And this is being least stable. Am I right, kids? This is being least stable. So without electrons, they are beggar. They are searching for electron. So who is in maximum need of electron? Who will easily accept electron? Definitely he is maximum hungry for electrons. Am I right? It is maximum hungry for electron and it is least hungry. So it is best oxidizing agent, best possibility to show reduction, maximum tendency for reduction, and that's why it's the best oxidizing agent. I hope that everyone got it. It is clear to each and every one of you. It's clear. Now, if you know only this option, you could have done that. Am I right, kids? Am I right or not right? Everyone got it. Is it clear to all of you? Now, Now move towards question number 10th. Go towards question number 10th. Do let me know what should be the answer of 10th question. If it is clear, kids, don't forget to show me green hearts. If it is clear to all of you, never forget to show green hearts. Remember that. Mark my words. Increase the speed. Very good, my cool tube. That's the correct answer. So which of the following transition does not exhibit variable oxidation state? Transition. Transition. If transition would not have given, then we have gone for what? I don't know. But which of the following transition element does not exhibit variable? So do you know that if zinc would have been given, zinc, by chance they have not given zinc, if they would have given zinc, then maximum strengths would have got confused. So scandium shows only plus 3, plus 3. Mercury shows two types, Hg 2 plus and Hg 2 plus. Mercurous and mercury. Copper shows 2, copper, cuprous and cupric. So all of these not possible, only scandium is possible. Is it clear? Now 11th question. 11th question, everyone. Question number 11th. Focus on 11th question. Let's see who is going to give the correct answer. First of all, do let me know you are enjoying or not. Everyone, are you enjoying or not? Do let me know, kids. My one humble request, Baba is making concept clarity or not? Do let me know that Baba is making concept clarity or not, kids. Do let me know, everyone. I want to ask everyone that Baba is making all the concepts super clear or not. Make the chat moving with very high speed if the answer is yes. Enjoying, very good. Have you ever studied the things in this way? Have you ever studied the things in this way? Chezian, today you got late. I was waiting for you. Very, very important things were going on. Now from tomorrow, I will take keep 2 sessions. One inorganic at the same time and one organic in the evening time. Evening means not at 7, afternoon time, better to say. For you kids, I will come with the questions and I will explain all the questions along with answers. What time will be suitable? Do let me know. For organic questions, what time should I come? What do you want? Which time? Tomorrow I will keep 2 sessions. One for questions of coordination chemistry and second for organic chemistry. Do let me know the timing. One timing will remain 7 p.m. This is fixed for inorganic chemistry. Sashi, welcome. You people got late. Why? Why you people got late? Baba was missing you. Now, my dear students, 4 o'clock is okay, or should I keep it at 3? 4 or 3? Do let me know. I think 4 p.m. 4 to 5 or 4 to 5:30. 90 minutes duration. I will complete 1 chapter's question. Everyone, first of all, make a promise that you will come at that time. Otherwise, if I'm missing, what will happen? I will not feel good. I'll be not having that much of energy. Everyone, make a promise that you will come. Why you people got late today? First of all, do let me know. Chezian, Sessi, I was missing you. In the comment section, you have to write down, not right now, not in the chats. In the comment section, you have to write down which organic chemistry chapter should I come with. I think I will come with the awesome chapter, that is GOC, right? GOC, I will come with GOC. Now, what is the answer of this question? 11th one. Do let me know what is the answer of 11th. Fast, quick, make it out quick. 11th. Everyone, 11th. Fast. Quick, kids, fast. Only 5 minutes are left. 5 minutes, just 5 minutes. 7th. 11 is going for 7th. And 11th question is there. Question is also 11th. Which of the following configures 3D series metal exhibits the largest number of oxidation state? Yeah, definitely. This is your like manganese. This is like manganese, and manganese shows maximum oxidation state. So it is simple question, done and dusted. This one is a very simple question. No problem is there. Very simple question. Now, next. Yes, 11th question. 11th. Oh, 11th is repeated. Already done. 12th question. 12th question. This already I taught you. This already I taught you yesterday, if you remember. If you remember, this already I taught you. Yes, very good, Arvind. You also got late. Do let me know what's the answer of 12th. 12th, what's the answer of 12th? Arvind is going for 2. 12th, chromium is a reducing agent in nature, because you know that chromium 3 plus will have its how many electrons? Chromium is 24, 3d5, 4s1, donated 3, so 3d3, and T2G half filled stability, T2G half filled stability. So in chromium, configuration changes from D4 to D3, achieve half filled T2G. Very good question. It's a question of crystal field stabilization energy. Already I taught you yesterday. Have I taught you? Have I taught you? Yes. Now go to question number 13th. Move to question number 13th. What should be answered? Wait. 13th question. 13th. Once, right now I taught you. This though I taught you today only. 13th one though I taught you today only. 13th. Why not 4? Why not 4? So into configuration changes to from D4 to D3, not D4. It's donating 1 electron. See, it's donating 1 electron. It's changing from chromium. Chromium, what they have given? They have given chromium 2 plus. So chromium 2 plus means that one has gone from here, one has gone from here. So it is 3d4, 4s0. It is coming from here to here. 3d3, 4s0. So what they are writing in this? They are writing d4 to d3 to achieve half filled. Okay. d4 to d3. Chromium 2 plus is a reducing agent. What they have written? Configuration changes from D4 to D3 to achieve half filled T2G. And if configuration changes from D4 to D to achieve half filled D. Half filled D subcell T2G. T2G differences. Let me tell you, very good question asked by you. If they are not degenerated, they will remain in the same energy level like this. Then 3 electrons will be like this. Now it is not half filled. It's not half filled. See, it's not half filled. In T2G, they are like this. They got bifurcated. T2G and EG. So this question is anaconda. By chance, this option is given over there. If they would have given this to be over here, then this question would have become really anaconda question, kids. Anaconda means everyone will mark the answer, but it will bite you. It will give negative marks. Anaconda means negative marks. Very good thing. I will explain over there. 11, don't worry. Whenever I'm going to take, I will explain each and everything. No need to worry. 11, no need to worry. Or I will do one thing. I will teach also. I will Reducing reducing in nature means will undergo oxidation, reducing agent. Yes, Arvind, that means reducing agent. Now is it clear? Now this option and this option, there is too much possibility of getting trapped, too much, quite possibility of getting trapped. Very good question, right? Now 13th one. Now today only, story of Florida and Oxy. If you know the story of Florida and Oxy, I taught you today. Story of Florida and Oxy. Do you remember? Today only I taught you this thing. So you can easily answer this question. Easy kill. I would like to say it's an easy kill question. Easy kill. Now 11-11 I will do one thing. 11-11 I will do one thing. While moving with questions, I will teach also, I will explain also. Should I keep one marathon of organic chemistry? How many of you want? Not everyone, not everyone. So what I will do, I will explain questions with the concept in more detail, right? 11-11, answer for 13th. So answer for 13th is quite clear. The what answer I have given is correct. That one is correct. First is correct. First is the answer. Because here they have not mentioned T2G. If T2G is not mentioned what? Not mentioned T2G. So it is wrong. It's wrong. It's wrong and that is correct. First is the correct answer. Got it? First is the correct answer. Got it? Okay, 11-11. Then I will plan for it. Don't worry. I will plan for it. Don't worry. Now, okay, 13th one. 13th one, still 14th. What else? This is missing. Okay, 13th one. What's the answer of 13th one? Yeah, 13th one. First solve 13th one. Everyone first solve 13th one. 13th one. What's the answer? Yeah. Sorry, my cool tube. Sorry. Okay, 11-11, I will keep marathon. For organic chemistry, I will keep marathon. Okay, don't worry. Day after tomorrow. So I will do one thing. Tomorrow, I will go with easy or tomorrow I will go with physical question, right? Then day after tomorrow, I will keep one long marathon of organic chemistry. Will you share it to everyone? Day after tomorrow, I will keep one long marathon of GOC. Right? Day after tomorrow, I will keep one long marathon of GOC along with questions and concept clarity. Concept clarity and questions, right? Full day marathon. Sunday, how many of you want? On Sunday, how many of you want long marathon of organic chemistry? Do let me know. The whole GOC first I will complete. Do let me know. Will you share it to everyone on Sunday? Yeah. On Sunday, how many of you want long marathon of organic chemistry? Do let me know. Very good. So I will complete whole GOC along with all the questions on Monday. So everyone, today, in the morning tomorrow, I will ask my team to make a thumbnail for GOC, and on Sunday, I will take whole Sunday GOC, right? Long marathon, right? Baba will teach you, not only teach you, Baba will make you perfect, the perfect in organic chemistry. On Sunday, GOC, organic, completed organic chemistry, Baba, 11th and 12th. Wow, but I will make, yeah, thank you. Now see, 13th, what's the answer of 13th question? 13th, everyone go with the 13th question and do let me know what's the answer. 13th. Yeah, now that's a very good thing. Yeah, Jyoti, say. Jyoti, most welcome. Do let me know. What's that suggestion? 2. Arvind, you are right. Second, fluorine, it provides stability through lattice energy. Today only I taught you. Today only I taught you. Now, 14th. What's the answer of 14th? Now it's 14th. Very good questions. Very good questions. Very good. Very good. Okay, Visham, very good. Chezian, organic, very good. Now tell me the answer. Answer of this question. Fast, make it fast. Only 5 minutes, 3 minutes more. Second, highest oxidation of manganese fluoride is Mn4, whereas highest oxidation. This is true, true. Oxygen has ability to form multiple bond. Very good. Now see, you got 2 questions. What I told you, the oxy and fluoride story. Fluoride and oxy story I taught you. You got it. 2 questions you got from there. Now, that's really fantastic. Now, here is another question. See to it. Fifteenth question. Question number 15th. Among the following, first, the order of oxidizing power. Yeah. This too I taught you. This too I taught you. This too I taught you. Right now I taught you. Madhu, Chezian, do let me know. So its correct answer is definitely chromium, molybdenum, tungsten, vanadium, chromium, nothing. Carbons, tin, carbon, silicon, germanium, tin, lead. This is wrong. Why this is wrong? We know inert pair effect. Lead, plumbus is stable, and carbon 4 plus is stable. So it's wrong. It's wrong. Now chromium. Let's see chromium. Chromium's which oxidation is stable? Oxidizing power. Oxidizing power. They are talking about oxidizing +6. +6. So it is need of electron. It is maximum need of electron. So this is also wrong because it should be on maximum. Oxidizing power, MnO4 negative, chromium, vanadium, and chromium, molybdenum, tungsten. Chromium is in which oxidation state? X -8. -8, -7, CrO4, CrO4 +6, CrO4, 4 दूनी 8, 7, कुछ गड़बड़ है, K2 CrO4, 6 +6 oxidation state, +6 oxidation state, so it's also wrong. Only one option is correct. Only one option is correct. This is correct because manganese and then chromium. We know that manganese is having very high SRP value. Mn +7 is having very high SRP value +7, and then chromium +6. So this answer is correct. Second, how many of you got it? How many of you got it? Do let me know how many of you got it. Now another question. This though, leave it because it's not from here, but let me tell you the answers. 16th answer, 16th, because it belongs to some other group, but you can answer it over here if you want to give. My cool tube, what's your question? Sir, since we all are at different level of confidence, can we get question paper from you, try to solve and then attend the marathon? Yeah, that's very good suggestion. It's a very good thing. So let's do one thing. Tomorrow we can keep one class for solving questions, and then we can check our level, that how much you are in need of, from where I should start. If you say, if everyone, but don't write now, don't write now. You can write in the comment section, okay? Then I will check. Are you getting my point? I will check, then write down in the comment section. Okay. Metal. This is simple question. Metal. Silver wants to remain in silver form. So mercury and silver, they are the only two cases. Mercury and silver, So this should be the answer. Now what should be the answer of 17th question? 17th question. 17th. 17th. Which of the following pair of ions have same value of spin only? So you can do what you just write down the electronic configuration and whatever the element which set is getting. Okay, let me do for you. Let me do it for you. You should know, science teacher, very crazy man, felt cold, felt cold. It is 26 and it is 27. So 27, just write down reverse 7 to 3d7 and 4s2. This is the trick. Cobalt 3 plus. 3 plus, that means 2 electrons gone from here and 1 gone from here. So 3d6. 3d6 means 4 unpaired electrons. So 3d6, if you write like this, 1, 2, 3, 4. So you fill the electrons. What do you get? 1, 2, 3, 4, 5 and 6, 4. So n value is coming out 4. Is it visible to all of you? N value is coming out 4, right? Now see, if I write down here, now simple, why to write down? You know that this is 26, this is 27, 26 minus 2, 26 minus 2 is coming out 24 and 27 minus 3 is also coming out 24. So same, why to write down the configurations? Apply simple logic. Are you getting my point? Thank you, Chezian. Thank you. So no need to write down the whole configuration. 26 minus 2. 26 minus 2 is 24. And 27 minus 3 is also 24. Anyways, this is clear to all of you. Now see, another one. Now how to solve this question? Should I tell you how to solve this question? Should I tell you the way how to solve this question easily? Should I tell you? 18th one, how to solve it easily. Should I tell you, kids? Should I tell you? Do let me know. Now see the way. The magnetic moment of divalent element in aqueous solution, if its atomic number is 25. Atomic number is 25. So any element's atomic number 25, just write down reverse of it. 5, 2. 5, 2. Now divalent means remove 2 electrons. So if I say it is manganese or something else, so manganese 2 plus, then it will be removing from here 3d5 and 4s2. So 3d5 is there. So definitely number of unpaired electrons 5. So 5 point something, 5 point something. Whatever the number of electrons unpaired, add something. Suppose if I say, if 4 unpaired electrons, n value is 4. So 4 point something, 4.9. If 3, then 3 point something, 3.86. If 2, then 2 point something, 2.76, like that. 1, then 1.73, like that. Means whatever the number of unpaired electrons are there, its Bohr magneton will come out a little bit more than that. Little bit, 4 point something, 3 point something, and reverse of it, if it is coming out 5. If n value is coming out 5, then Bohr magneton will be 5.93, and if it is coming out 5.93, then its unpaired electron will be, remove that before that digit. It's very simple. Magnetic moment formula is under root n into n plus 2. Bohr magneton is equal to number of unpaired electron n into n plus 2. Clear? N into n plus 2. Is it clear? N into n plus 2. I hope this is clear to each and everyone, right? Right. Everyone, is it clear? Now see. Now, this much for today, and rest of the questions, only one slide is left. You have to tell me the answer of these questions. Which question? Let me tell you. Answer of question number this one. First you have to study from NCERT. That's your homework. Do the reading from NCERT. Reading first. Do the reading from NCERT and then do this question. Then I would like to say do this question 24th and then 25. So it's for your homework. And homework questions are from here 21, 24, 25, and from the last slide, how many were left? 19th and 20th. 19th and 20th. No, don't do that. Do not do that. Only these many questions. They are your homework, right? These 3 questions are your homework. Do let me know the answers in the comment section. Will you? Do let me know answers in the comment section. This is all for today. This is all for today, my dear friends. So the best thing is that we have gone through each and everything and I have explained each and everything, kids, each and everything. The whole D block I have explained. Yeah, they are full concept. I have gone through each and everything from D block. Yesterday I took class, that is potassium dichromate and KMnO4, each and everything I have told you. Today I have taken the class and you see all the questions we have done. Very good. Thank you. Thank you. So let's make it like this. Bye to all of you. Good night. We'll meet tomorrow, right? Bye-bye. Take care, kids. And do let me know the answers in the comment section. And do let me know each and everything, whatever you are requiring in the comment section. Baba will make it possible. Baba is promising the whole day and night Baba will teach to make you perfect. That's Baba's promise. Yes. Okay. Bye. Good night. Good night, kids.